Go finding it too. We'll say things. Sat there, I was like, oh man, I missed that. They want to do that. Okay. What time does that one start?
In like a few minutes.
Okay, well,
Yeah, don't worry about making any noise or anything. You're good to go. Have fun. Okay, gonna get started here in just a few minutes. Gonna let some people roll in. Yep, gonna let some of you just work your way in here. All right. Okay. The review itself will not be posted on Canvas, but it will be here for you to stream on our YouTube channel. So, all right. So, if you are here, do say hello. Do say hello. I'm not saying there might be some extra credit involved, but I'm just saying that might be the case. All right. So we're going to go through the material that we've learned so far. Go through all the stuff that we've done. Hopefully this will be a fairly, not brief, but hopefully that we will be able to go through and give you a fairly good overview of the material. I'm good, thank you. Yes, tonight is, I don't have to wake up at 10 in the morning to teach tomorrow, which is just perfect. So, get to sleep in, which is super neat. Although I have my midterms. So, anyway, moving along. So, we're going to start with Lab 1. So, remember, the first day of class, I told each of you that doing geology in general is a bit like time travel, right? It's a bit like exploring history in a very interactive way, that we can take rocks and we can hold something in our hands that is thousands, if not millions, or even sometimes billions of years older than us. So we talked about how we measure geologic time. Okay? So what I'm going to ask you to do for the first part of the test, I am still putting the finishing touches on the test, but we are going to go through most of the things that will be on it, or so all the things will be on it, and we might even cover some things that will be on later. But the first thing we need to talk about is the eons and the eras, right? Remember this, how we measure geologic time, right? Eons and eras. So eons and eras. So tell me, people in chat, which one of these is longer? Which one of these measures more time? Eons or eras? Eons or eras? What do we got? Anybody? Eons or eras? Which one's longer? I'll give them a minute. Eons, that's right. Eons are longer. That they cover more geologic time than all of the other ways that we have used to condense that time. Okay, so remember there are four eons that we talk about, right? So would anybody like to attempt to tell me what those 4 eons are? was 4 eons. So anybody just want to throw one out there, that's fine. We'll put them in order. So 1, 2, 3, 4. There are 4. 1, 2, 3, 4. 4. Anybody want to take a guess? Hazard and answer. Come on, team. Please don't make it from talking to the camera the whole time. All right. Hadean, perfect. Hadean is the first one. All right. All right. So the Hadean, the Archean, perfect. Okay. Archean. Proterozoic. And Phanerozoic. Very good. The Phanerozoic. So, for the test, I am going to give you basically what is a word bank, right? I'm going to ask you to order these. So, I'm going to ask you to put these, the very first question, I believe this is the very first question on the test, is asking you to order the Hadean, the Archean, the Proterozoic, and the Phanerozoic. Okay? And the second question on the test is going to be for you to give me a detail, one detail about these. And we're going to go over this right here. So, would anybody like to give me something, maybe a word to use for the Hadean, So the Hadean eon, right? What defines the Hadean eon? Anybody like to take a guess? Remember lab 1 when I asked you to come up with a mnemonic learning device, right? Okay. Anybody want to tell me about the Hadean? What happened here, right? What happened here? Go once, go twice. Okay. Well, Hadean, not quite. We're getting there. So the Hadean was hot and hellish. Hot and hellish. All right. Fire. That's right. Fire. Remember Hadean, Hades, like the underworld. Terrible, fiery, not a place you'd want to be, right? So hot and hellish. Okay, the Archean. The Archean, there's kind of a very important word here for Archean. Word arc. So what happened here? Perfect. Yes, Mr. Mobile Suit and Holly, you are correct. In the Hadean had, yes, the moon, right? The moon, the great home wrecker came through and smashed into our planet. Or an object came and smashed into our planet and gave us the moon. But in the Archean, we had single cell organisms. Single cell organisms, right? So that was the beginning of our primordial beginnings. Were right here, all right? But the Proterozoic, what happened here with the Proterozoic? How can we define, let's see, invertebrates? Perfect, multi-celled organisms. Or I cannot spell. Multi-celled organisms. And the Phanerozoic, there are a few things you could give me for this. I think I gave you 3. So can any of you give me any details about the Phanerozoic, the period in which, the eon in which we are living? The eon in which we are living. Anybody? The Phanerozoic. Life forms, that's right. So what in particular about those life forms what about the life forms was important about the Proterozoic? Or the Phanerozoic, sorry. What is important about these? Vertebrates. Vertebrates, very good. So, vertebrates. And yes, it is the current eon. Also, much more tectonic stability. And if you remember, and this is one that I will also take this answer, in the Phanerozoic, grass. So this is, yes, currently it is the shortest. Phanerozoic was also the rise of grass, thanks to which grazing animals were able to proliferate, and agriculture was allowed to thrive. And when agriculture thrived, so did we. So, all right. So, how are we feeling about the eons? The eons. Eons. How are we feeling? Any questions about this so far? All right. Okay, so the eras. Listen, there are a lot of eras. I am not going to ask you. Wait, no, there's only 3. We're not talking about periods. Sorry. The eras. Got my notes mixed up. There are 3 eras that I would like you to know. 3 eras I would like you to know. All right. So, the 3 eras to know are, yes, Paleozoic, Mesozoic, Cenozoic. Okay. So, the Paleozoic, I gave you a very good example of something that existed during the Paleozoic. I would like you to give me some form of, that's what I'm looking for here, some form of definition. And we're going to talk about animals. We're going to talk about animals when we talk about these 3 eras. So the first era, the Paleozoic, there was a certain type of species or certain habitat that species happened to thrive in the Paleozoic. So fish, that's right, the ocean. So ocean, so this is where we got sharks. Listen, sharks have been around forever. Forever. They're older than the dinosaurs. I mean, if that's not an apex predator, I don't know what is. So, Paleozoic, let's get sharks. Okay, now somebody out there, earlier, who we got here? Mr. Dark Ice HD was kind enough to discuss one of the dominant species, that's right, the dinosaurs in the Mesozoic. Dinosaurs. Dinosaurs in the Mesozoic. Okay. And the Cenozoic was what? What did we see come to power during the Cenozoic? Cenozoic. What do we got here? People. And what are we? What are people? What are people? Mammals. Mammals. Yes. Also, I will take grass. Strange as it sounds, grass as we know it did not exist during the time of the dinosaurs. They had their own particular vegetation, but that is also an answer I will take for the Cenozoic. Okay, and the only question I am going to ask you about the periods, there's only one question I'm going to ask you about the periods. There are only 3 you have to know. Only 3 periods you have to know. And this is one that we talked about. And one of these will be really easy. One of these will be so ridiculously easy. I am going to ask you what periods in which the dinosaurs lived. What periods in which the dinosaurs lived? That is the only question about the periods I'm going to ask you. You do not need to know all of the other almost 24 of them. So what periods in time did the dinosaurs live? They do not have to be in order, but I will put them in order here. That's right. So the Triassic, the Jurassic, and the Cretaceous. Those are the only 3 periods you need to know. So to begin with, your test will start with, the first question is going to be, what's longer, an eon or an era? And you'll have to answer that. And then I will ask you to write down in order, and I will give you each of them, in order, the Hadean, the Archean, the Proterozoic, and the Phanerozoic, and I will ask you to give me a detail about them. We'll ask you to give me a detail. And then we will move on to the eras. Move on to the eras, so we'll have the Paleozoic, the Mesozoic, and the Cenozoic. And again, I'm just looking for a single detail that you can give me about each one of them. And to finish off lab 1, the only periods you need to know, and I will put this, are the periods in which the dinosaurs lived. So the Triassic, the Jurassic, and the Cretaceous. That is all that I will ask you. Okay, any questions about this at all? Any questions while I transition to lab 2? Any questions? All right. I do not see any questions. No? Okay. We're going to go to lab 2. Actually, you know what? We're probably going to do 2 and 3 together, because 2 and 3 are hand in hand. So let me go to open up lab 2 and 3 together. Give me 1 second. Assignments. All right, lab 2 and 3. All right. So this is where we got into plate tectonics. Plate tectonics, okay? And talking about boundaries. So plate tectonics. Labs 2 and 3. We're going to do these together because they go hand in hand. The first question I will ask you is how a hotspot forms. So remember, a hotspot is a volcanic upwelling of magma or an extrusion of magma that does not happen at a plate boundary, right? So does anyone want to tell me how a hotspot forms? Anybody want to tell me? How does a hotspot form? I will take a minute and let somebody answer. I'm just going to have a seat. And just wait. A hotspot. So, hotspots. I think Hawaii. Think Hawaii. All right. Okay. I'll give it another couple seconds, see if anybody wants to take a stab at it. Yes, that is correct. That is very much. So remember what happens when a hotspot occurs, right? Yes, perfect. So a hotspot occurs. when you have crust, right? And most of the time it is oceanic, right? And you have magma. Remember magma when it's inside the earth and lava when it is outside. You have magma that kind of pushes its way up through the crust and it breaks through the crust, right? And what happens is that crust melts, and eventually it builds up over time to create an island. But here's a question, and this is going to be a question too. The movement of tectonic plates, is it constant? Is it constant? Is the movement of tectonic plates constant? Anybody out there? The movement of tectonic plates constant? That is correct. They are not constant. They are not constant. And do we remember the formula we use to chart that movement? What is the formula? So what is the formula that we use to chart that movement? The hint here is speed. What do we use? Anybody want to take a stab at it? There's a specific formula. Blank equals blank over blank, right? So what is the velocity formula, Holly? So velocity equals what? What? Yes, distance over time. Velocity equals distance over time. Very good, very good. So what we will do then is, remember how I asked you to calculate the distance between two islands, and then I was like, hey, here's two rocks you found to tell how old they are. I'm not going to ask you to do that on the test. I'm going to want you to know the formula, but I won't ask you to calculate it. But then what we're going to get into, now that we've talked about the hotspots, right, and we know how to chart them with velocity equals distance over time, like I said, if it's up here on the board, it's going to be a test question. So you have to know that, yes, velocity equals distance over time. Okay, but we talked about the crust, right? We talked about the crust. And here we're kind of breaching into lab 3, we're breaching into lab 3 here because 2 and 3 go together. So that crust, right? That oceanic crust. What kind of materials make up the oceanic crust as opposed to continental? So the oceanic crust is made of dense, yes, it's Thursday, is made of very dense material, which means that there is a term for these rocks or this material that is dark and dense and is what we got here. That's good. That's good, Holly. So there's a term for these. There's a term for crust that is higher in iron and one that is higher in silicates. There is a term here. There are two terms we use. One starts with an M and one starts with an F. An M and an F. So Felsic and mafic. Perfect. Felsic and mafic. So oceanic crust is mafic. And mafic means that it is high in iron and low in silicates. But if it is felsic, it is high in silicates, but low in iron. All right. So now that we know this, we talked about plate boundaries. Before I erase this, are there any questions about hotspot formation or the composition of the crust? Any questions about hotspot formation or the composition of the crust? Feel free, this is the time. All right. Okay. Yes, the midterm is online. You will not come to class. If you come to class, I won't be there. So, all right. So, there are three boundaries that we talked about in class. So remember, and like I said, I'm a big fan of physical learning devices. So you have one that pulls apart, right? You have one that pulls apart, okay? And do you remember what that's called? The one that pulls apart. What is that called? We got, yes, so which is the one that pulls, yep, of two plates that are moving away from each other? I think so. Need to get to that. Yeah. So divergent, yes. Divergent, so that's two plates that are moving away from each other. So two plates that are moving away from each other. All right. I am fairly certain there will be some. Like I said, I haven't written the entire test yet. I'm not quite done with it, but we're getting there. All right. So the boundary that moves toward one another, right? Where one subducts beneath another. What is that called? When two plates come towards each other, but one subducts beneath another. What is that called? Convergent. Very good. Convergence. Okay, now before we get to this one, what is the last? Where two rub against one another and create friction. What is that called? When two rub against one another and create friction. What is that? What do you call that? Transform. Very good. Okay. So when you have two that are next to one another, so it's like an overhead view. You have two that are moving in separate directions, and they create friction against one another as they move. So remember, and like I said, this is how I remember it. Some of you can have learning devices. So you have the divergent, pulls apart, right? The convergent, one dives beneath another, okay? And your transform is when they create friction in their movement against one another. But I saved convergent for last because you are going to have to draw me a picture for the final. There will be a portion where you will have to draw me a convergent boundary. I'm not sure if you remember doing this in class. I believe we did this as an extra credit assignment, but there will be a convergent boundary. Two things about that. One, be sure that it is a JPEG, a PNG, a PDF. Be sure to check the file extension before you turn it in. I believe there will be another place where you will have to draw me something. Please be sure that it is either a JPEG, a PNG, or a PDF. Do not send me this HEIC thing because that's a mess. Or It can be a docx, I suppose. That's fine too. Also, don't go online and just find a picture. I know, I've seen them all. So, all right. So you have to draw a convergent boundary. So the convergent that I'm going to ask you for is oceanic to continental. Now, why did I ask you for this? Well, if you remember, we talked a good bit about rocks and rock formation, okay? So I'm going to ask you to draw me that boundary. So what you're going to give me, we're going to go through this together. So you will have an oceanic plate, right? And it will dive under another plate, okay? You'll have your continental. And then what will happen is as that oceanic plate dives, the material, not liquefies, but it melts. And remember we talked about gravity separation, it starts to rise. So this will start to rise and work its way through that crust and create a volcano, right? So I will ask you to draw it and label it. So I will want you to label the oceanic crust, the continental crust, right? You can, if you wish, you can give me the asthenosphere that is underneath the lithosphere that is underneath our crust, right? I will want you to show me how the magma rises through and pushes through the other plate to create the volcano, okay? And be sure that you also, I will probably just ask you to give me a very short description of what is happening here. So basically what you'll tell me for that is the oceanic plate is subducting beneath the continental plate, melting, and the magma pierces through the continental plate, creating a volcano. So, okay, any questions about this? Any questions about the boundaries? Divergent, convergent, transform. Megatron, yes. All right. Any questions? So the other things you need to know, so we talked about the time of the dinosaurs, right? We talked about the time of the dinosaurs. They lived on a continent. Lived on a continent. And what was that continent called? What was that continent called that the dinosaurs lived on? That was one giant mega continent. Pangea. That's right, Pangea. So Pangea, we know, obviously broke apart. I mean, you know, there's oceans and places between continents now. What boundaries were responsible for that breaking apart? For that movement, tip here, a movement of the continents away from one another. What boundary was responsible for this? Divergent. That's right, the pulling apart. So the continents, as we know them today, were once pulled apart and are now in their current positions. So, all right. And one last thing, what is the outermost layer of the Earth called? What is the outermost layer? So something sphere. What's the outermost layer? What do we got? Go ahead. No. The outermost layer. Oh. The lithosphere, that is correct. Technically correct. Technically correct, which is the best kind of correct. So, yes, the lithosphere. The lithosphere is the outermost layer of the Earth. Okay, so that is what you need to know for labs 2 and 3. 2 and 3. All right. So now we're going to move on to lab 4. Do you have any questions about labs 2 and 3? I taught them together because they are so closely related. So while I prepare for the next one, do you have any questions at all? Any questions? Okay. All right. So now we're going to talk about, if there are no questions, all right. Oh yes, only one plate drawing and it will be convergent. It will be convergent. And the convergent will be, it's also important to note, I want oceanic to continental convergence. So, all right. So, you were asking about rocks. I can now say, getting to this section of my notes, that yes, there will be rock identification, but let's put a pin in that. We'll get back to it. Okay. So, igneous rocks. Igneous rocks, we're going to talk about next. Igneous rocks. All right. So, let's start out with, we are going to talk about the identification of igneous rocks. And there are two traits that we look for identification for igneous rocks. Can any of you out there in YouTube land tell me what the identification, what we can use for that identification? What two things are we looking for? Two things. Two. That's right, texture and composition. Very good, Holly. Texture and composition. So texture and composition. All right. Okay. So let's start with the easier one. Composition. There are three compositions, and we've already talked about a few of them. We've actually already touched on this when we talked about the crust. What are the three compositions? That is right, Holly, you are on the ball today. Felsic, mafic, and intermediate. Okay, so when something is felsic, right? What does that tell us about its composition? When you look at a felsic rock, I dropped my marker. When you look at a felsic rock, right? That is right, high in silica, low in iron. What does that tell us about its color? Does that tell us about its color? Anybody? A felsic rock. What does that tell us about its color if it is high in silica but low in iron? So, low in iron, and it is, yes, lighter in color. Okay, so for example, actually let's, we'll get to it here in a minute. Here is a felsic rock. I know it's not very clear. I actually had a review before this, and I know the rocks don't come through very clearly. But here's a felsic rock, right? Lighter in color. So we know then that mafic must be what? Mafic must be what? Talking about its composition. If one is high in silicate and low in iron, what is mafic? What is mafic? What you guys got for me? A mafic rock is what in color? And what does that tell us about its composition? Tell us about its composition. That's right. High in iron, low in silica, and darker in color. So, high in iron and darker. Okay. So we have this, but, you know, let's overcomplicate it as scientists want to do. What about intermediate? What can you tell me about intermediate? What happens here? What do you got, class? What you got? Intermediate. That's right. See? Perfect. In the middle. No. And now we're going to take a short breather to talk about the bonus questions. So there's going to be a bonus question. There will be 2 of them, bonus points, right? And here is, yes, my favorite rock. I have paraded this in front of your class. Every single class period, I've used it for multiple examples. What is this, class? What is this? Anybody know what my favorite rock is? We've talked about it every time. Don't know?
I'm not answering your question.
Oh. Do you know? It's rhyolite. That is correct, Holly. It is rhyolite. So that is 1 bonus question, right? That's right, we do. But I also have a rock that I detest. It's terrible. It's boring. It's the potted plant of rocks. What is this? I will ask you my least favorite rock. I will probably say that I think it's a potted plant of rocks. What is this? That's andesite. That's right. Yeah, we don't like andesite up in here. We don't. Andesite's bad. Andesite's bad, okay? It's boring. It's just a gray hunk of rock, man. Thank you. All right. So, now that we have talked about composition and we've had our break for the bonus question, now we need to talk about texture. Now we need to talk about texture. Okay, so there are 5 textures we talked about. There are 5 textures we talked about. I am going to ask you to name them. You don't have to worry about spelling as long as I can understand. As long as I can understand what you are trying to tell me. There are 5 textures. So what are the 5 textures? Don't give me more than 2. Everybody, oh, that works too. That's fine. Thank you, Holly. So, yes, we have Phaneritic, Aphonetic. You're good. You're good. Thank you. So we have Aphonetic. Going to put that one at the top of the list here. Phaneritic. Right? Porphyritic. Glassy. And Pyroclastic. All right. So, the aphanitic and phaneritic they go hand in hand with one another. How can we tell the difference between an aphanitic and a phaneritic rock? What is the difference? What is the difference between these 2 rocks? Go ahead and send me what you got. Show me what you got. Cooling speed, that's correct. So, we are talking about cooling. So an aphanitic rock, I will only ask you one detail. Just give me one detail about each of the textures. So, an aphanitic rock, how would you know it's aphanitic? What does it have? What does it have in terms of maybe the size of its crystals? An aphanitic rock has what? Small crystals, that's right, small crystals. While the Phaneritic rock has what? I mean, they are inverse. So a Phaneritic rock, what does this have? Yes, visible crystals. Visible, large crystals. But a porphyritic rock, we put this where it is on the chart. I don't think in your manual it's actually on there, but we put it here for a reason. This is basically the intermediate of the cooling world over here. So what does a porphyritic texture have? Yes, so it has intermediate. Yes, that's good. It has both. Both textures. So like the rhyolite I paraded in front of you all semester, you see that, I know it's not very clear, but you can see that there are some salt and pepper textures here, right? Perfect. Yes, so this rock started to cool inside the earth, but was then extruded, and those crystals that had already cooled and solidified inside the earth were then encapsulated in these aphanitic textures. Perfect, perfect. Okay, when something is glassy, what does that tell us about how it cooled? Glassy. So we know obsidian is glassy, right? So how did obsidian cool? Extremely fast, that's right, instantaneously. So, obsidian, yep, cooled in water. So it hit water, right? So this happens from extrusions that come up, right, through the hot spots are a great place for this, and lava will hit the water and cool, and the crystals will fuse together, right? The crystals will fuse together and give you a nice glassy texture. Okay, the last one is pyroclastic. There's a certain word I'm looking for pyroclastic. I'm going to ask you for this word in particular. I know there are many different ones. Right, so if it cooled in the air, there's a word I'm looking for. And when you answer this question, this is the one I want. It has something. It has vesicles. Very good. Has vesicles. Yep. So that is where we're at for igneous rocks. Okay, so let me take a look at this one more time. Make sure I got, all right. So what I'm going to ask you to do is I'm going to give you one rock. This will be, I think, the back page of the test. You will have one rock, and I will give you a rock of, I think it will be 2 different igneous rocks. And I will ask you, you do not have to know the name. I do not have to ask you, you do not need to know the names of the rocks unless you're trying to do the bonus. That case, you need to know rhyolite and andesite, right? But I'm going to ask you to tell me the texture, and the composition. I can promise you that the sample that I choose, that the sample that I put on the test, it will be clear. There will be very little to no question as to what it is. So there will be 2 igneous rocks, and you will have to tell me the texture and the composition. Okay? All right. So do we have any questions about igneous rocks? Any questions at all? Igneous rocks. Anybody? I am here to answer them. All right. Okay, so we're going to stop. We're going to talk about sedimentary rocks. And we're going to get into the second image that you have to draw me for the test. All right. So, sedimentary rocks. There are a few things you need to know. There are a few things you need to know. So, what are the 4 steps to making a sedimentary rock? The 4 steps of making a sedimentary rock. Four steps. You may give me as many or as few as you know, and we will put them in order. 4 steps. Okay? Yes, weathering. And there's one down here. Deposition. There's 2 more. Transportation, yes, and there's one more. One more. The last one, the very last. Oh, you're good. You're good. There is one more. It is the process of making rocks. Something-fication. Something-fication. Rock-fication. Yeah. Rock-fication. Who's with me here? Who's with me? Who can give me that word? What is the word we use? Yeah, that's the one. Lithification. That's perfect. Lithification. Okay. These are litho. Good. Yes, litho is the prefix for rocks. So we talk about weathering. We're going to talk about chemical and mechanical, right? But we are going to focus more on the mechanical. On the mechanical. All right, team. So there are four particle types you need to know. 4 particle types. So who can give me those 4 particle types? And props to you if you can give me them in order. In order. What do we got? Those 4 particle sizes. Gravels, sands, silts, and clays. Gravels, sands, silts, and clays. All right. So here's the thing. You're going to have a matching section on the test about this. And you're going to have to match the particle size to the particle itself. But if you can remember, gravels, sands, silts, and clays. One more time. Gravels, sands, silts, and clays.
Clays.
That's right. All right, guys. One more time with feeling. Gravels, sands, silts, and clays. Hey. All right. So I'm going to give you the particle sizes for these. So bear with me here for a second. Okay. Gravels, sands, silts, and clays. So gravels are your largest. And here we have a sample, right? And you can see the gravels are these large pebble type things here, right? So your gravels have a size of 2 millimeters and above, right? So your sands, here's a piece of red sandstone. You can see these particles, these individual sand particles, right? They are the smallest particle size you can see with the naked eye, okay? And then you have, I like using this fantastic siltstone here that actually has a nice fossil in it. It's kind of neat, right? Got little scales. Okay, and this has the consistency of flour, okay? And then, like the glue that they are, here, I'm going to show you the conglomerate again, but you will see that there are things holding this together, holding the larger pieces together, and that is some clay mixed with silt. There is every particle size present in this rock, but it is a lot of the clays that hold them all together that make it possible. All right. So this will be a matching section. So gravels, sands, silts, and clays, and you have to match to the particle size. But if you know the order, you're good to go. All right. So let's keep going here. We're almost done. So transportation. There is only one thing you need to know about transportation, and I'm just going to give this one to you here. Larger particles do not travel very far. Travel less, right? Where smaller particles travel farther. We are going to get some metamorphic. Hang on. All right. So the sedimentary, so remember your gravel, sand, silt, and clays, but the larger the particle, the less it travels. The smaller the particle, the farther it travels, right? So do you remember, I think one of my classes I took outside, and we drew this, and this is the second picture you're going to have to draw me. Okay. And this is the marine model of deposition. So we have weathering when you break a rock down, right? You have your transportation when you move that rock, okay? But then it gets deposited. But we spent a good amount of time talking about the marine model of deposition. So I am going to draw that for you. And here's what it will be. Let me get a fresh marker here. All right. So you have, oh, that's terrible. Doubt you guys can see that at all. Oh, perfect. All right, so we have what is an area leading to the ocean, right? So let's, yeah, look at my fantastic art skills. It's like Picasso and Salvador Dali rolled into one. Okay, so what will happen is these particles will get transported, right? But because the larger the particle size, the less they can travel, they will deposit at different areas throughout the area with which they lose energy. So how does this work? Well, you'll have an area that has your gravels, right? Your gravels. So you will have your conglomerates here. Your conglomerates. Okay, but then you'll have your sandstone, your sand, right? So you get your sandstones. Okay. And then you'll get your silts, your siltstones. And surprise, surprise, you're going to get your clays. Get your clay stones. Okay, so what does this model tell us? Well, here's what we're going to do. We're going to draw one last thing here. Is this a good one? Yeah. So the farther out you go, larger particles, smaller particles. Larger particles to smaller particles. But wait, there's more. There's one last thing. And this was the question on the lab that I think gave people the most trouble. Was I asked you to identify a rock that was very light in color. And to to tell me how it deposited, because we talked about the marine model. And remember, we discussed about how some, perfect limestone, how some animals will help with the creation of that rock. When we were talking about sedimentary rocks, I showed you guys a shell limestone. Right, so you will have what will be basically a lot of very small suspended materials that precipitate. They precipitate and they create this limestone, right? So you will have this, what is almost a solution, that helps precipitate into this limestone. This is the final part of the marine model. Be sure not to forget this part, because yes, we talked about the others, but there is another layer here that comes from the smallest of the small, very tiny particles, almost microscopic, that are deposited and create their own area of their own layer, if you will. So the model shows us how various particle sizes deposit based on their capacity to be transported. So gravels are very large, right? So they aren't transported as far. So they deposit first, and then in an order, depending on particle size, down to what is almost the molecular level here, where you get limestone deposits. You will have to draw me this. You will have to draw me a marine model. For the record, do not send me the same one that you did for the lab. Do not send me the same one you did for the lab. I will know. So, all right. So do you have any questions about this? Any questions at all? I will leave this here for a minute. Any questions at all? Step back for a second in case anybody who rewatches this wants to take a look at the model. All right. Okay. Clean this off, and then we're going to go for the very last part, our very last section here. We're going to talk very briefly about metamorphic rocks. Very briefly. All right. Okay. All right. So we're going to talk a little bit about metamorphic rocks. Metamorphic rocks. Okay, so when we talk about metamorphic rocks, I only asked you for two words. Anybody know what they are? 2 words for metamorphic rocks. Anybody? I'm just going to keep cleaning this up. 2 words for metamorphic rocks. That's right, Holly. Heat and pressure. So heat, and heat and pressure. Right, listen. Heat, pressure. One more time. Heat, pressure. Okay? Did you guys catch that? I'm not sure if you caught that. Heat. Huh, imagine that. Wonder what comes next. Oh, pressure. Okay. All right. Heat and pressure. Because we didn't talk about it much, that's all I'm going to ask you to know about metamorphic rocks. We did not get into metamorphic rocks that much. Yes, they do foliate. But I'm going to ask you, for simplicity's sake, because this did not get the time that igneous and sedimentary rocks did, I will merely want you to know the formation, how they were formed, as this did not get the time that the other labs did. So I'm not going to ask you to know a whole bunch about something I didn't have the time to teach you. So heat and pressure. That's it. Okay, that has reached the end of the material that I have for you. Do you have any questions whatsoever? I am here to answer them. Any questions? Don't be shy. Any questions about the test itself, about what's coming up after the test? Anything at all? I'm just gonna sit here. My second favorite rock, diorite. Diorite is neat. All right. Any other questions that you have? Anything at all? No, they will not be identifying them. I will simply ask about them. Yep. The question will legit be, what is Mr. King's favorite rock? And I will probably put in parentheses, here it is. The test will open on Thursday. You will have until Friday to get it done. So you have 2 days. 2 days to get it done? Oh, yeah. Once you open it, you're going to have 2 hours. You're going to have the entire length of a class period with which to do it. I doubt it will take that long. If I had to give you a tip, draw the convergent boundary and the marine model of deposition before coming into the test. If that was my teacher pro tip to all of you. Draw the marine model and the convergent boundary before opening the test, given that I have told you that they will be on there. I'm not going to bamboozle you. It will be there. So that will make it easy on you. So you can very easily just go through the test at your own speed. Yeah, thank you all for showing up. This has been fantastic. If there are no more questions, I guess we will bring it to a close. And I will see all of you next week. Do come to class. Remember that my attendance policy is kind of tightening up a little bit. So I hope to see you all next week. All right. Good luck on your midterm. Yes, I will do so. Sorry, this weekend I was busy. So, all right. Good luck. And if you have any questions, comments, or concerns, feel free to email me, as I am going to be as available as I can here for the next couple days. So, all right. Good luck.